Okay, so question 5, here's an example. So it says perform the indicated operations, which I personally hate those directions. I would prefer if they said divide, multiply, or something like this, because here they're not telling you divide. They're not really, because you don't see a division symbol or multiplication symbol or anything like that. You have to just assume that it's a fraction, so I'm going to divide here. And we
Okay.
want to write the answer in standard form. So we've got complex numbers in a fraction, and this is one of those multi-parts to kind of lead you through the steps. So got 9 plus 2i over 4 plus 6i. So with complex numbers, we don't like to have complex numbers or I basically in the denominator. We want to keep it in the top of a fraction. And so it says perform the indicated operations. What it's actually asking us to do is sometimes it's called rationalizing the denominator because we have this irrational thing, this I, that's not in the denominator. And we do this with square roots as well. We don't like to have square roots in the denominator. So the directions that you may see here, simplify, you might see divide, you might see, as this particular problem says, perform the indicated operation. And you might see something like rationalize, which isn't technically used with imaginary numbers because they're not really rational, but it's the same sort of idea. So step 1 is we want to get rid of that imaginary part in the denominator. And we do this by kind of using some tricks. So with imaginary numbers, we know we've got I, which is of course equal to the square root of -1, but that's not really useful. But I squared is equal to -1. So we want to get rid of the I in the denominator, and we do that by trying to get an I squared, so that way the I will become -1 and that it kind of disappears and we have a number there instead. So if we can make that I be an I squared, then it will get rid of the I. So the first thing you might think to do would be multiplying it by I. But if you multiply that out by I, you get 4i plus 6i squared. And so it does turn the I to an I squared, but then we have an existing I there. And we have another I. We just created a new I, and that doesn't really help us because now we have another I to get rid of. So just multiplying by I to get an I squared doesn't work here. What we do instead is we multiply by the conjugate, which is basically you multiply by the denominator, but you switch the sign in front of the I. So instead of a plus 6i, you multiply it by minus 6i. And whatever we do in the denominator, we have to also do in the numerator. So we're going to multiply the top and the bottom by that 4 minus 6i. So if I want to write good notes here, because we're talking about note taking. So what I would, if I was, so I'm not writing good notes here because I'm teaching, and when I'm teaching, my notes are different than what I would write on a piece of paper. Very different style here. But if I was actually, writing this in notes, I would write this exact words here at the top, writing the actual directions here, and then I would write the problem. So if I was taking notes, I would write down the directions, which I just copied here, and then I would have the problem, which is the 9 plus 2i here. So now what I would do when I take notes is I'd actually write down the instructions, the steps. So that way, when you're doing a problem like this similar, somewhere else, you have those steps in front of you. And the nice thing about here is that they're basically telling you the steps. Like this is why the homework problems are kind of step by step like this, because they're telling you what those steps are that you should be writing down. So that would be our first step, is to multiply the numerator and the denominator by the conjugate of the denominator. Now, this does not make sense to most people because it's got all these words and you're like, what is going on? So when you're taking notes, you want to kind of break it down in your words for you to understand, in addition to whatever the problem is telling you. So I would say step 1, multiply the top and bottom. So notice that instead of using our technical terms, numerator and denominator, I'm just using top and bottom, which makes more sense. Which you know what that means when you're looking at a fraction. By the, I'm going to just say opposite of the denominator. Which is switch the sign of the I term. So I'm sort of explaining in words what we're doing here. So when you're taking notes, you're going to want to write a lot more than you see in the book, a lot more than you may see on a video, because a lot of this I explain in words, or other videos are explained out loud, but they're not written down. And you want to kind of put it in your words so that it makes sense to you, something that you can follow. And I like to use different colors so it kind of stands out. So I took what the words were and then I basically translated into what does that actually mean. So our problem that we had, I'm going to rewrite it. We had 9 plus 2i or 4 plus 6i. And so I'm multiplying by the denominator, but with the opposite sign of the I term. So you can even kind of color code here to indicate, see that those are their opposite signs, so you can visually see what just happened. So that way, when you're looking at this later or you see another problem, you're like, okay, this is what I need to do. So I'm going to just bring over the question here. So they just want you to literally write that down, what we're multiplying by here, because we're just stepping through it.
While you type that in, can I ask if that if say the 4 on the bottom was a -4 plus 6i, would it still, when we flip it, would it still be -4 minus 6i?
Yes.
Okay, just want to make sure.
Yeah, you only change the sign of the I part. You don't have to change the sign of the other part.
Okay, thank you.
Yep, that's a very good question. So part 2, it says to apply the distributive property in the numerator, then use the definition I squared equals -1, multiply the conjugates in the denominator, combine like terms. It's giving us like 5 different things to do here. This little caret symbol we use to indicate an exponent if you're typing, and that also works if you're typing it into Alex. You can use that and it'll put it in the exponent. Okay, so we're not going to do this all in one step. So like the question gives it as like a 3-step problem. It's not a 3-step problem. You have multiple things to do here. First step will be, we're going to FOIL. It says to use the distributive property and multiply the conjugates in the denominator. We're basically foiling on the top and the bottom. So step 2, FOIL top and bottom. So I'm going to just rewrite what we have here so that I can show the foiling step. And so if we do the top, so FOIL first, outside, inside last. So if you need to, write notes to yourself, that's what it stands for. So 9 times 4 is 36. And you can even color code if it helps. 9 times negative 6i. So 9 times, oh, I'm really bad with my nines. 9 times 6, 54. Okay. Do you guys know the finger trick of your nines?
No.
No? Okay, so I'm going to stop sharing.
I
So,
have no clue.
no clue. Okay. I'm going to briefly share my camera so I can show you the finger trick because I just literally did the finger trick on my own because I'm just bad at multiplying. Of course, you can use a calculator. So when you're multiplying by nines, and I got to make sure that I do this correctly. Let's say I do 9 times 1. I put down one finger, and then how many do I have to the left of that? 9. 9 times 1 is 9. 9 times 2, bring down the second finger, is 1 and 8, 18. 9 times 3 is 20. I can't really do the 2. You've got 2 fingers here and then 7 over here. So 9 times 3 is 27. So 9 times 4, we've got 30, 5, 6. 9 times 5, 45. So it's a really nice little trick here. So I was going through and I'm like, okay, 9 times 6, put down 6 here, and then that gives me 54. So fun trick with the nines. Totally, you don't have to feel bad doing that as an adult. I do it. But otherwise, you can use your calculator. But that is the 9 trick.
That is kind of neat, but someone really had way too much time on their hands.
It's a really nice trick that happens because it's a base 10 system and we have 10 fingers. I think if we had like 6 fingers, it would probably work with multiplying by 5s or something like that if we had like a base 5 system. But yeah, it's a fun little trick. I learned it when I was a kid and I still use it today. So yeah, so that gives me, that was negative 54 and then I. So you can see I'm color coding here. And the color coding is nice because then when you go to check your work, you can double check of my arrows, make sure that you're multiplying correctly. If I color code each arrow separately, I can make sure that I know which multiply got me where. So inside is 2i times 4, so that's 8i. And then last terms, 2i times negative 6i, so that's negative 12i squared. And so now I'm also going to FOIL on the bottom, and this is where you'll see that this is why we multiplied specifically this way. So first terms, 4 times 4 is 16. Then the outside, 4 times negative 6i, so that's negative 24i. And then the inside is 6i times 4, and that gives us a positive 24i. And this is why we're doing it this way, so that those I terms, that middle stuff, cancels out. So that way, this actually gets rid of that I, plus we'll end up with an I squared that we can cancel. So then our last term, 6i times negative 6i, is a negative 36i squared. So step 2, FOIL. Step 3, simplify. If it would help. I may be a little dyslexic because I apparently cannot spell. There we go. Simplify. So now we're going to add our like terms and convert any I squareds to I. So simplify and turn I squared equals negative 1. So we're going to turn all of our I squareds into negative 1. And so sometimes it helps when you're showing work this way to just take what you had from the previous step. So that way you can then go to the right to kind of show how you're simplifying here. So when we add like terms on the top, I'm adding my I things together. So a negative 54I plus 8I. Let me do that on my calculator. So I still have my 36. That gives me negative 46I. Then I have this minus 12, and I want to convert the I squared to negative 1. So that's negative 12 times I squared. So now that's going to be negative 12 times negative 1. So if you want to color code this way, like highlighting, you can then highlight what you added together and then what the answer that gave you. And then you can also highlight here that we converted that I squared to negative 1. So you can kind of visually see what you did. And that way, when you're doing a similar problem like this, you can follow, okay, I did the stuff in yellow, so that's what I'm going to do next. You can kind of follow the patterns and use the color coding to help guide you on what you need to do. And then we're going to do the same thing in the denominator. What's really nice is that the negative 24I plus 24I cancels out, so there's basically no, that basically just equals 0. I can write that little note there. Equals 0, so that just disappears. So then we have minus 36, and then we're replacing I squared with negative 1. So we've added our like terms, we've turned I squared into negative 1, and now we want to continue the simplifying process. So we're gonna go through our order of operations here. So I'll just rewrite what we had. And so order of operations says our multiplication has to happen before our addition. So we're going to be doing our multiplications here first. And I am including the minus signs there because those are essentially like negatives. So at this point, because we're going to be doing multiple steps for simplifying, I'm just going to start working vertically. But I have 36 minus 46I, and then negative 12 times negative 1 is a positive 12. And then we have 16, and then a negative 36 times negative 1 becomes a positive 36. So you can see we have no I in the denominator anymore. That was the whole point of all this. Then I need to add my like terms on the numerator and the denominator. So I'm just going to kind of highlight those so you can see what we're adding. So 36 plus 12 is 48 minus 46I, and then 16 plus 36 is 52. So now we've got this fraction. We can't really, there's not really anything else that we can do at this point because we don't have like terms on the top. And this is the point that they wanted you to get to on part 2 here, where you get your denominator at 52. So on the top, I can write 48 minus 46i. Now, part 3 is we want to separate the fraction because we want to put it in the form where you have a number without I added to something with I. So that is the next step. So I'm going to just copy those directions. Oops. So if I'm following my step numbers, let's see, that was step 4. So now we're on step 5. Separate fractions and reduce. Because when it says simplify each fraction, that's basically what it means, is to reduce the fractions that you have. So we're basically undoing when you add fractions. When you add fractions together, the denominator stays the same, and then you put them together on the top. So we're kind of separating that out. So this gives us 48 over 52. Then we have our minus sign, and then 46 over 52i. So we're just taking that fraction and separating it. And they put their I on top of the fraction, but I find that a little harder to read, so I put it to the right here. I just find it a little, it's visually better for me to kind of see that, so it doesn't look kind of lost in there. And so now we want to reduce each of these fractions. So 48 and 52, I know I can divide those by 4. So this is how I show my work when I'm reducing, as I indicate what I'm dividing the top and the bottom by. 46 and 52, let's just start with dividing by 2. We can reduce it more if we need to. So 48 divided by 4 is 12. 52 divided by 4 is 13. 46 divided by 2 is 23. 52 divided by 2 is 26. And 23 is prime, so that's not going to have anything in common 26. So neither of these reduce anymore. And so now we're in the form that they wanted, a plus bi, or in our case, it's going to be a minus bi. So I just took my answer, separated it out, and then you're reducing those fractions, and you have them as 2 separate terms. So when you're putting your answer here, and just make sure that I have 12 over 13, and they give you the I right there, so all you need to do is, and they give you the minus sign as well, so all you really need to do is just type in the fraction here. And then, oh, you can't see it, but there, we got it right. So that's how we do a problem like this. And normally, I mean, this explaining it and writing steps like this, everything that I've written down takes a lot longer than it would actually take if you're doing this on a quiz. When you're taking a quiz, you're not writing down all of these directions each time. You're just writing the math part, but you use your notes so you know what you do each time. So you look at your page of notes for this, you follow the directions, but then on your piece of paper, you're only writing the actual math part, not all of these words. So it doesn't take as long when you're doing this like on a quiz than it would on like taking notes. Taking notes is probably 5 times as long as when you're actually doing it, because you're writing down all of these extra directions here so that you know what to do, so that you can use your notes later on. Divide the rational expressions.
Yeah.
So you have to factor here. So I bet you the error is in your factoring, because that's usually what goes wrong. So I'm going to just do the screenshot kind of.
And I like that if you submit an assignment, it allows you to just only have to do one of them, the one that you got wrong over versus the whole thing.
Right. I mean, if you want to redo the whole thing, I think you still can.
I'm good.
But yeah, I mean, let's just have you focus on the ones that you got wrong. You know, if you got it right, you don't really, I mean, if you want more practice, you can, but there's no reason to force you to do it.
Right.
Okay. So we are going to divide. So clearly the directions here are telling us to divide. We have the division symbol. So here it's pretty clear. It's, you know, it's not confusing what you need to do. They're pretty obvious about what you need to do. The question is, do you know what those steps are once it tells you what to do? So, when we're dividing rational expressions, so step 1, so it's the same thing when you're dividing fractions. So when we go back to elementary school or whatever, when you learn about fractions, when you divide by a fraction, you multiply by the reciprocal. So dividing by a fraction means that instead we multiply by the reciprocal. So you're taking the fraction that's after the division symbol, you flip it, and you turn it into multiplication. So we get p squared minus 20p plus 100 over p squared minus 6p minus 40, and then multiplication, and we don't use x because now we're dealing with letters, we don't want to get confused, so we just use a dot there, and then I flip the second fraction. So that's your first step, is to turn a division problem into a multiplication problem. Step 2 is then to factor everything. So this is, you have to really know your factoring, because otherwise, if you get your factoring wrong, you know, the whole thing kind of gets wrong. So sometimes what I find is really helpful is to kind of put labels, because you've got basically 4 things here. We've got 2 fractions with a top and a bottom, and I usually say top left, top right, bottom left, bottom right to kind of label so that I know what I'm factoring. Top right here is 7. There's nothing to factor there. So we have 3 things that we need to factor. So you can kind of keep yourself organized by having labels so that you can keep track of your factoring, or you can color code and say, okay, my top left I'm going to do in yellow, and I'm going to just do that in one color. Bottom left will be in a different color, and you can color code that way. But I usually do the labeling kind of thing. So let's just first start by factoring the top left. So that's 20p, or p squared minus 20p plus 100. So this is one where you want to factor by guessing and checking, because it won't take too long and you do not have a number in front. So I'm going to set up my parentheses and I put in my variables. And then I'm looking for 2 numbers that multiply to 100. So that's 1 times 100, 2 times 50, 3 doesn't go into it, 4 times 25, 5 times 20, and let's see, 6 doesn't go into it, 7, 8, 9, 10 times 10. And then that's as many as there are, because if I start going up, I'm going to start kind of backtracking, because you can see once I'm going to start going back into these numbers. So I've written down all of my numbers, and we talked about last week about how to know what signs you have. So we're multiplying to a positive, adding to a negative, so that tells us that both of these are going to be negative numbers. So I can just immediately put in my negative signs here because they're both negative. And so we're looking for the pair that adds to negative 20. And so that's negative 10, 10, and negative 10. So I can put those in. So I've just factored the top left. And so now we want to move on to bottom left. You know, let's go to the next one. So the bottom left is p squared minus 6p minus 40. So this is another one where I would use guess and check, because we do not have a number in front of the p squared. So we've got my p's in there. I'm multiplying to a negative, but adding to a negative, so I'm going to have opposite signs. So I know that one of them is going to be plus and one of them is going to be minus here. So now we're multiplying to negative 40. So I'm going to just write down the numbers that multiply to 40. So 1 times 40, 2 times 20, 3 doesn't go into 4, times 10, 5 times 8, 6, 7, and now we're back to 8. So those are all of our choices. And because the middle number is negative, the bigger number here is negative. So I can indicate those. Now I'm looking for the pair that gets me to negative 6. And that would be 4 and negative 10. 4 minus 10 is negative 6. So I'm going to put my 4 with the plus and then my 10 with the minus. So now I factor the bottom left. Top right is just a single number. There's nothing to factor there. So now we want to factor the bottom right, p squared minus 100. So this is one of those special ones that you want to learn the shortcuts for, where you have just two terms. This is the difference of two squares. So you really want to be able to recognize this and kind of memorize when it's in this form, because it will speed up your life. Well, getting good at factoring will really speed up everything, but this one particularly you definitely want to memorize. So this is another one where we've just got our p times p, and it's opposite signs, and they have to have the same number because they add to 0. So we have to basically, the square root of 100 is our missing numbers. That's 10, because 10 times 10 gets you 100. So it has to be the same number, just opposite signs, so that the middle cancels out. So this factors to p plus 10, p minus 10. So step 2 is to factor everything. I've factored. Step 3 is to start cancel out the common factors. So now I need to make sure that I write everything in its proper place. So top left, we had p minus 10 times p minus 10. So I'm going to write that in. Bottom left, p plus 4 times p minus 10. If I can get this to actually move on me. Oops. P minus 4. Other side. P plus 4, p minus 10. We had 7 on the top of the fraction. And then our bottom right is p plus 10, p minus 10. And so when we cancel things out, we have to cancel out from the top and the bottom. So you can't cancel out only on the bottom or only on the top. It has to be one on the top, one on the bottom. So like we've got a p minus 10 and a p minus 10. And it doesn't matter which p minus 10 I cancel. I have another p minus 10 that I can cancel with a p minus 10. On the top, then I'm left with a 7. There's nothing else left to cancel out with. Basically, that's everything that we can cancel out. And so then step 4 is where you actually then do the multiplication. Multiply. So on the top, I've canceled out the p minus 10, p minus 10, so I only have 7 on top. And then I combine, I've got a p plus 4. I canceled out a p minus 10, and then I'm multiplied by a p plus 10. So I generally leave it in this factored form. I don't bother multiplying it out from here. But that's simplified, and that would be your final answer. Now, I'm actually not sure if Alex will accept that, so we will find out. So let's make sure, let me put in. Let's check. Yes. So Alex doesn't force you to then multiply out that denominator, so you can leave it like that. Saves you some extra steps there.